Okay, as we get into trigonometry here, we're solving some proportions because we're dealing a lot with similar triangles and proportional relationships. So we're practicing solving some proportions that you've likely seen before, but the algebra steps up a little bit here in some of the difficulty. The way I like to solve these is with cross products. So that works with any proportion, and it's a fact that's true about any proportion is that if you have equal ratios, which is what a proportion is, the cross products are true, or cross products are equal. And I can demonstrate that with a really intuitive one. The fraction 1/2 and the fraction 2/4, right? We know those are equal. They're both a value of 0.5 or 50% or 1/2. And if I put an equal sign between them, we can clearly see that if I multiply the cross products here, if I do 2 times 2, that's going to give me 4. If I do 4 times 1, that's going to give me 4. And they have the same cross products. Those numbers are equal. So that is something that exists with any proportion. And a proportion, again, is an equal sign between two fractions, between two ratios. So this is a proportion. It was given as a proportion. I already started circling kind of here in color. I'm going to do 3 times b plus 3 as one cross and 7 times b plus 8 as another cross. And that is going to give me an equation that I can solve because the cross products, by definition, have to be equal. All right, so let's do this. 3 times b minus 3 and 7 times b minus 8. Now, a few of you guys might be shouting at the screen right now because I deliberately drew this in a kind of a common error. People will often do this, and all they'll do is multiply the 3 times the b. And you can see the way I wrote it there, it looks like that. But it really needs to be 3 times all of this. And the best way to notate that is to put parentheses around this entire expression. So it's going to be 3 times all of this guy. And we can see that here. That's going to set up the premise for distributing to each of those pieces inside. So we want to do the same thing over here. It's not just 7 times the b, but it's 7 times the entire b plus 8. That whole thing is being multiplied. So I'm going to set that up for distribution. I'm going to multiply that out. 3 times b is 3b. 3 times 3 is 9. There's subtraction between them, so it's minus 9. 7 times b, 7b. 7 times 8 is, what, 56? Yeah. Doing all this math without a calculator. Okay, so now what I need to do is get my b terms on the same side, get my constants on the same side. I'm going to subtract 7b over here. I like having my variables on the left, even though it's going to give me a negative coefficient. It's all right. So it's a negative 4b minus 9, right? I'm trying to keep everything organized, keep my equal sign here. This is canceled. I'm going to have a minus 56 on this side. I'm going to add 9 to both sides now to get my constants all on one piece. Again, I'm keeping my equal sign here in the center. This is canceled. I'm going to have a minus 4b here. And then I need to do negative 56 plus 9. And you can hear me step away to grab a calculator. So let's clear that here. I'll go back and do my 7 times negative 8. Make sure that's right. Yeah, I did do it right. We're going to add 9 to that, negative 56 plus 9. That's going to give us a negative 47, right? And then I'm going to divide everything by a negative 4. That's going to cancel. That's what I wanted. I'm going to get b equals. I don't think this is going to go in there evenly. In fact, I know it's not because that's an odd number. So I'm going to take my negative 47, and I'm just going to divide that by, a negative 4. And it's going to give me 11.75. So that is my final answer. That is the value that I could substitute into the original in order to make it true. In fact, I can demonstrate that right now. If we put 11.75 back into the original, so here I'll just put my answer. I got b is 11.75, right? That's what I got when I solved. I'm just putting it up here so I can see the original. If I do 3 over 11.75 minus 8, that should equal 7 over 11.75 minus 3. And that is definitely not something I want to do in my head. So I'm going to type this into the calculator. Another parentheses note here, if we're going to type this in all in one fell swoop, it's really important that we do all of this in one thing so that the calculator knows that we need to subtract that 8 first before we do that division. So it's going to be 3 divided by 11.75 minus 8. Gets us about 0.8, or gets us exactly 0.8. Do the same thing over here. 7 divided by 11.75 minus 3 gets us 0.8. They do equal. 0.8 equals 0.8. That is my solution. The last thing I'll do right here, I just want to show you how if I didn't put the parentheses on that, you'd get a different answer. The reason is that calculator thinks you're just dividing by 11.75, and then after that, you're subtracting the 8. And it's really important that the calculator knows that that whole thing is in the denominator, and that's why those parentheses are so critical. All right, hope that's helpful. Message me anytime with questions.